Welcome back, reinforcement learning. This lecture I explain navigating with the Q learning, hyperparameters and discount factor. Okay, last session I explained navigating with the Q learning, what is Q learning and Q learning with the grid world game example. Okay, in the continuation of the navigating with the Q learning, this session I explain the hyperparameters and discount factor. Okay, hyperparameters are the very play the key role in Q learning. They are used to update the Q values of the state and action pairs in Q function. Okay, in reinforcement learning, Q learning is a very important. So we have to tune the hyperparameters like in reinforcement learning, like deep learning and machine learning. In Q learning, the hyperparameters are learning rate and discount factor. Okay, learning rate and discount factor. These two are the very the key hyperparameters in Q learning update rule. We are using the update rule in last session how to update the Q values of this state action pairs with the Q value update rule. In that we have using the alpha and gamma. Alpha is the learning rate, gamma is the discount factors. These two are very influential parameters. These are influence how quickly an agent learns from the environment and how it evaluates the future rewards. The learning rate influence how quickly the learning rate influence how quickly an agent learns from the environment, and discount factor used to influence the evaluate the future rewards. These two are the important parameters in Q learning hyperparameters. In hyperparameters are the variables. Okay, these are the variables we are using in learning process. These are the these variables control the learning process. Control the learning process of algorithm, and they are not updated. They are not these hyperparameters are not updated during the training process. They are not updated during the training process. They are set. They are fixed before learning begins, and they are continuous. They are fixed in during entire training pages. Okay, these are updated after completion of the training. We are update the hyperparameters. During the training, they are fixed. These two here, the Q learning, the two important hyperparameters are learning rate. It is represented with alpha, and discount factor, that is it is also it is represented with gamma. Okay, hyperparameters are variables. They are fixed during the training process. They are not updated during the training process. In learning rate, okay, learning rate we are represented with alpha. It controls how much the Q learning algorithm adjusts the Q value estimates, after each update, after each episode. Okay, it essentially dictate how response the agent is to new experience. So it controls how much the Q learning algorithm adjusts the Q value estimates. This learning rate, the learning rate values, we are using the learning rate in deep learning also. Same concept, the learning rate in Q learning also. In the low learning rate, the learning rate is low, means alpha is small. The alpha is small means the algorithm will only make small updates to the Q values after each learning steps. The updates are very small. So the updates are very small means it leads the slow learning. So but it is the slow learning, but it is a stabilize the learning process. It stabilizes the learning process. So making this an incremental improvement over time. So low learning rate means the updates are very low and it takes the more time, and so it is a slow learning process, but it stabilizes the learning process. If you are taking high learning rate, alpha is large. So updates are very large updates. the algorithm will make significant updates. The algorithm will make significant updates to the Q values after every action. So, the learning process, the speed of the learning, but it causes instability. The drawback is it causes the instability. So, the agent may overreact to the single experiences with outliers or noisy data. So, low learning rate, the updates are very small updates. So, learning is slow learning, but it is stabilize the learning process. With high learning rate, it updates are significant updates, and the learning process is speed, and it is instability in learning process. Okay, this is the learning rate. So, the learning rate trade-offs between convergent speed and stability. So, we are taking high learning rate, there is a instability, but it is the speed, the learning process. If the learning rate is low, it is the stabilized in the learning process, but it is a slow learning. So, we have to adjust the learning rate, which one gives the best results for our problem. Next hyperparameter is discount factor gamma. Okay, discount factor gamma is a parameter. It determines how much the agent values future rewards or immediate rewards. Okay, here discount factor we are using the future rewards are discounted by this discount factor. Future rewards are discounted by this factor. Okay, this discount factor range between 0 and 1. This discount factor range between 0 and 1. The role of gamma or discount factor, here the discount factors are the weight applied to the future rewards. The future rewards weights is applied here. This indicates prioritize the future rewards, and it allows the agent to make decisions, not only maximize the immediate reward, it has to choose the immediate reward or future reward, long term value. The discount factor discount the future reward. Based on the discount factor value, agent choose the immediate reward or it choose the future rewards. So, for example, the gamma value, discount factor value close to 1, the discount factor value between 0 to 1, the gamma value close to 1, the agent will have consider the future rewards. If the discount factor close to 1, the agent look into the future rewards. And gamma value, the discount factor value close to 0, agent choose the immediate rewards. Agent created the short term rewards means immediate rewards. Okay, if the gamma value close to 1, the agent focus on long term gains means it's focus on future rewards. The gamma value close to 0, it focus on short term goals means it is choose the immediate rewards. For example, this discount factor control the balance between we have to choose agent give the decision to agent take the decision based on the discount factor. He will choose the either immediate reward or long term reward. So, well tuned discount factor ensure that the agent achieve the optimal balance. Okay, optimal balance which is the best rewards, cumulative rewards. So, here one example here, the state S, the two actions are there, the +1 reward, after that 0 1 reward. If I take in the action here, in this part, first one is the +1 reward, next 0 rewards. In state S, we have choose the action B, the 0 reward, and next one is +1 reward. The cumulative both are +1 reward. Then cumulatively, if we are taking action here, the cumulative reward is 1. If we are taking action B, the cumulative reward is 1. Action B, it results in immediate reward is 0 followed by 1 in the next step. If action A, it provides immediate reward is +1 followed by 0. Here, even though the both actions lead to the same cumulative reward, that is the +1. Okay, but the timing of the rewards will influence the agent decision depending on the value of gamma, that is the discount factor. The gamma is close to 1. The gamma is close to 1 means the agent choose the future rewards. The agent choose the future rewards. If the gamma is equal to 1, here the immediate action is either plus 1 and 0. Here gamma is equal to 1, the agent choose the future rewards. So, if the gamma is close to 0, the agent choose the immediate rewards. Agent choose the immediate rewards. In this example, gamma is equal to 1 means agent choose the long term. So, long term means in this case, if you are choosing 0 plus 0, the long term you got the 1. If the agent is gamma is equal to 0 case, here you choose the immediate reward, that is plus 1, that is plus 1. If the gamma is equal to 0, you choose the immediate reward. If the gamma is equal to 1, you choose the future reward. You choose the future reward. Here, see here, agent in grid word example, for gamma is equal to 1, the agent tries to optimize the future reward. Consider all steps it will take throughout the game. So, gamma is equal to 1 means in future you will get the best rewards. If gamma is equal to 0.5 or gamma is equal to 0, in both cases the agent discount factor rewards by the half. Here 0.5 means half, focusing more on immediate rewards. If gamma is equal to 0, agent will greedily focused on immediate rewards. So, most the valued mode, see here, generally the plus 0.5 case, the agent must choose the immediate rewards only than longer rewards. So, gamma is equal to 0, you choose the immediate rewards. The gamma is equal to 1, the agent choose the future rewards. This is the grid word example. In hyperparameter tuning, we have to tune the both alpha and gamma to influence the agent to choose the best best learning process by update the alpha and gamma values and to predict the future values using gamma value in Q-learning process. The Q-learning, the learning rate and discount factors are critical hyperparameters that significantly impact the how agent learns from the environment, and it controls how quickly the agent updates. Okay, thank you.